Welcome students, Tom Harmer here, your accounting professor, and this is a demonstration of calculating the market price or present value of bonds. Now this example we're looking at here, Jimbo Corporation is issuing $500,000 of 8% 5-year bonds with semi-annual interest payments. The bond investors want a rate of 10%. In other words, the market rate is 10%. The issuer of the bonds wants to get the most they can for the bond, but the market, the purchasers, won't purchase a bond unless they can yield what the market is paying, the interest that the market is paying. So, in any case, we go from here. We want to calculate the market price, present value of the bonds, and we also want to calculate the closing price of the face. Closing price percentage of the face. Now if we come over here, let's go to this guy. This is if you get Wall Street Journal or even the Seattle Times or any paper, you pull up the security section and you go to bonds. You'll find the bond name that's available to purchase. You've got the maturity date. You've got the closing price. This is the percentage of the face of the bond that it's selling at. That's the yield, that's your estimated volume. So we want to calculate this number, plus we also want to calculate the dollar amount that we should be receiving when we sell those bonds. Okay, so let's move on here to now. So here's the question: in determining the market value of bonds, it's a function of three factors that determine its present value. We've got the dollar amounts to be received and the length of time until the payments are received, and what the market rate of interest is. So we come here, the dollar amounts to be received, the length of time until the payment amounts are received, and what the market rate of interest is. Now of course the bonds have their bond rate. So knowing the bond rate and the market rate, those two rates are going to help us calculate what the present value of the bond is. So, what is present value? Well, present value is how much you would invest today to receive a certain amount in the future. So in this exercise here, if we were what would we invest today if we were earning 10% rate of interest and we were going to receive that in one period, or say 1 year? So if it was a 10% rate of interest, how much would we invest today? Well, we divide the future amount by 1 plus the interest rate. So if we're receiving $1,000 a year from now, we divide that by 1.10, and that gives us $909.09. That is the present value of that $1,000 that's going to be received a year from now at 10%. So we can create tables based on the unit of 1, and so we can multiply the present value of 1 times any dollar amount that's going to be received down a year from now, and get how much we should invest today for that to earn that dollar amount at that particular interest rate. So we got the present value, whatever it is, times 1 plus the interest rate equals the future amount. So we have the present value, okay, here it is, 1 plus 10% equals 1,000. The present value, so we take that 1 plus 10% and we bring it to the other side of the equation, basic algebra. And so we're going to divide 1,000 by 1.1. And so the present value now equals 1,000 divided by 1 plus the interest rate. Present value equals 909.09. So let's go look at how that fits into a present value table. So there is the 9.90909 that we just calculated by using that formula for payment received, one payment received at 10% one period from now, okay, which would be 1 year. or whatever the interest per period is, okay? So that's how we calculated for one period right now. So this is what that looks like graphically. This is what we invest today, 109.09. 1 year from now at 10% interest, we're going to receive a $1,000 payment. So the present value of that $1,000 is 909.09. Okay? Now what if we're not going to receive that $1,000 for 2 years? Well, that means what we invest today is going to be less because it's got a longer period of time to earn interest. And this is compound interest, by the way. So let's look at that. So here's 2 years. So to calculate the present value for 2 years, we divide 1,000 by 1.1 for 1 plus 10%, and we divide it again by 1.1. So the present value gets less and less the more years out that payment's going to be received. So now, if you divide that out, that equals 826.45. So we come down here to our present value table, and you can see that the next line down, which is for the second period, is 0.82645, which is 1 divided by 1.1 divided by 1.1, and etc. for 3 periods, for 4 periods, for 5 periods, etc. So the next question is, what is the present value of a stream of payments? Because remember, bonds are paying interest payments every 6 months. So what is the present value of a stream of payments over a period of years? So we call those annuities over the life of the bonds. To compute the present value of an annuity, we need to know the interest rate, the number of interest periods, and the amount of the interest payments. So here we go. We're receiving that $1,000. We're receiving one payment in 1 year. We're receiving another payment in 2 years, and we're receiving another payment in 3 years. Now the present value of a payment of $1,000 in 3 years at 10% is 0.75132. The present value of $1,000 received in 2 years is 0.82645 of that 1,000. And the present value of 1,000 in 1 year is 0.90909. So if we add all of these up, all of these different present values up, that gives us the present value of an annuity. So we total 0.90909, 0.82645, 0.75132, and that equals 2.48686. If we multiply that times 1,000, that tells us how much we should invest today to receive $1,000 in 1 year, $1,000 in 2 years, and $1,000 in 3 years at that interest, at that market rate of interest. So here we go. Here's another picture of it here, 1,000 at 1 year, at 2 years, at 3 years, multiplied across. There's 90909, etc. 82645, 75132 equals 2,486.86. That's how much we should invest today to get $1,000 payments in over 3 years, 3 payments, and be earning 10%. So here's how it looks at the table. So this is the present value of an annuity of 1. Not the present value of 1, but the annuity of 1. So annuity means a stream of payments for every period. This is 3 periods. This is 10%. 2.48685. We multiply that times any dollar amount that we're proposing to be receiving. That will tell us how much we should invest today to receive a payment stream. So a bond, when we issue a bond, we've got 2 payments. We've got a payment stream, and we've got the bond payment at maturity. So we get the present value of the bond payment at maturity and the present value of the payment stream, and that'll give us the total present value of the bond. Said here, the selling price of the bond is equal to the sum of the present value of the face of the bond discounted at the investor's required rate of return, the market rate, plus the present value of the periodic interest payments discounted at the investor's required rate of return. So there's a picture of that. Here's the present value of the future payment of this bond 10 years from now, or 10 periods from now, which would be 5 years. And here's the biannual $5,000 interest payments on that bond and the present value of that. So here's the present value. This is a contract rate of 10%. That's the bond rate. And the discount rate is another word for the market rate. That is the interest rate that the investor is demanding, and that the seller of the bond, the issuer of the bond, can't sell it unless he matches the investor's demanded market rate. Okay, 100,000 due in 10 periods at 5%. That is 100,000 times 0.61391 equals the present value of that bond payment is $61,391. Now we're receiving $5,000 every 6 months for 10 periods. So there we go to our present value table, and we've got 5,000 times 7.721373, 38,609, and the present value of the bonds is 100,000. So this is where the contract rate and the market rate are the same. No premiums, no discounts. Now what happens if the market rate of interest is greater than the contract rate on the bonds? Let's take a look at that. So you have here the bond rate is 10%, the market demands 12%. So if you're an investor, you're demanding 12%. You're not going to pay face value for a bond that's only paying 10%. So what you do is they discount the bond. They sell the bond at a lower price to get you to invest. So that's the present value of the bonds has to be less. So if we've got it demanding a 12% rate, that 12% rate, that's what we're going to the annuity, the present value tables for, to calculate what we would invest today to earn 12%. Okay, to get $100,000 in 10 periods. We go to the present value table. Pardon me. We want 12% rate of return. That's going to be 6% every 6 months. Okay, so we're going to the annuity table to find the present value of $100,000 at 6% for 10 periods. So we come over here. Here's a present value of 1. Here's 6%, half of the market rate, 12%. 10 periods comes to 0.55839. So there you go. We go 100,000 times 0.55839 gives us a present value of that one payment 10 periods from now. And then the present value, we're receiving $5,000 every 6 months for 10 periods. What's the present value of an annuity of 1? So we come over here. Present value of an annuity of 1 at 6%. There's 10 periods, 6%, 7.36009. So there's your 7.36009 times your $5,000 gives you the present value of that payment stream. So the present value of the bonds is $92,639. So we're having to discount this bond. The difference between the $100,000 and the $92,639 is the bond discount. The opposite of that happens if the contract rate on the bond is greater than the interest rate that the market is paying. If the market is demanding 8% and the bond is at 10%, then we can sell this bond for more than the face. So in that case, we take $100,000 times the present value of 1 at 4%, 4% being half of the market rate that we're demanding. Okay, there's 4%, there's 10 periods, 0.67556, okay? Okay, 100,000 times 0.67556 equals the present value of that payment 10 periods from now. What's the present value of this $5,000 every 6 months that we're receiving when you take an 8% rate of return rate or 4% per payment? We go down here to our 4%, 10 periods, 8.11090, 5,000 times 8.11090. There you go. So there is the present value of the payment stream plus the present value of the maturity payment equals sale at a premium, $108,011. Let's take a quick look at the bond amortization schedule that we'd set up for this when it was sold at a discount. Okay, so we sold it at a discount where the market rate of interest was demanding 12%, but our bonds were only paying 10%. So we discounted it to $92,639. So here's our bond amortization schedule. Issue date. There's your discount that was given. There's the carrying value of the bond, which is the face minus the discount. $92,639. Our first payment, we paid $5,000 in cash, but we're amortizing this discount over 10 periods. So we divide 10 into 7,361. That gives us $736 that we're amortizing that payment. That is like additional interest we've paid because we sold it at a discount. We sold it at less than we have to pay it back. So we're amortizing at $736. So that's reduced. That's credited our unamortized discount by $736, brings it down to 76 or $66.25, and now the carrying value of the bond has gone up. When this reaches maturity, the carrying value of the bond will be the face of the bond. Will be the face of the bond. So then our total interest expense with that payment is the interest we paid plus the amortization of the discount that we gave when we sold it equals $5,736. Now just to show you how that's journalized, let's take a look at that. So July 1, we had interest expense of $5,736, discount on bonds payable $736, and a credit to cash of $5,000. So now let's take a look at our problem. We're issuing a $500,000 bond. I'll put that here, and we're doing that it's an 8% bond, but we're demanding a 10% rate of interest. So when we are discounting or getting the present value, we're doing that not using the interest rate, the contract rate, but the market rate. So that's going to be 5% for how many periods we got? It's 5 years, so that's 10 periods. So we're going to need to get the present value of 1. And we're going to come down here to the present value of 1 for 5% for 10 periods. So there's 10.61391. So I got 0.61391. Okay, now if I multiply, oops, I guess I need to increase. There we go. So I've got that fixed. So I'm going to go equals times, that's 3,306. I'll just go equal here, just take that right over there. Boom. So the present value of that future payment of $500,000 at 10% divided by 2 for 2 payments per year is $306,955. Now this is paying 8%, the contract rate times the face of the bond, or $40,000 per year, divided by 2 is $20,000. It's paying once every 6 months, so we want the present value of that payment stream over the next 10 payment periods. So we come down here, we've got now the 8% calculated the payment. So now to calculate the present value of those biannual payments of $20,000, we have to use the interest rate that we demand, that the market rate demands for their investment. So we go to the present value of an annuity of 1 table. Okay, for 10%, now that's biannual, so we're doing it for 6 months. We divide that by 2, so that's 5%. It's a 5-year bond, so that's times 2 is 10 periods. So that's a present value of an annuity of 1 factor of 7.72173. So we come up here and we enter 7.72173. That's our factor. Times the 20,000. It's going to go equals times 20,000 biannual payments, which equals $154,435. So I'll bring that over here. equals to, all right, so now the total of the cash flow of the biannual payments and the final payment at the end of the term of the bond, we add those two present values together. So that's $461,390 is how much we'd invest today. An investor would invest today in this 8% 5-year bond in order to get a 10% rate of return on their investment. So you see that the investment amount is less than the face amount. So when the interest rate on a bond is less than the market is demanding, they're going to pay less for the bond than the face. If the interest rate on the bond was greater than the interest rate demanded by the market, then it would sell at a premium, which would mean that it would sell for greater than the face of the bond. But this is a discounting situation here. So now we want to calculate the closing price as a percentage of the face of the bond. All right, so we could take the closing price divided by 500,000 less 2 points, and that'll give us our number because we have to end up at a full decimal price amount here. So I'm going to go equals closing price divided by 5,000 instead of 500,000, and that gives me 92.78 is the close price for the bond on the market. Now we need to journalize the issuance of this bond. First, we begin with our debits, and that's going to be our total cash received on the issuance here. So we have cash, and that's going to be, I'm going to just go equal sign here and grab that cash. Here's our debit to cash. Now it was sold at a discount, so that's going to be a debit to discount on bonds payable. So the discount on the bonds payable is going to be equal to 500,000 minus the price. Okay, so that gives us our discount on bonds payable, and then we have bonds payable, and that's your 500,000. And we put our explanation here as issue bonds 8% at 92.278. So there we go. We have calculated the present value, the issue price of the bond, calculated the closing price of the face percentage, and we have journalized the transaction. So there you go. There is a complete circle on calculating the issuing price of a bond based on the difference between the contract interest rate and the market interest rate demanded by investors. Thank you very much.